So here we go. I never have Reese's unless you buy it.
I feel like somebody needs to just get Reese's and put it in.
I don't know. I got things.
There is a Reese's.
I got strawberry Airheads because I don't like to eat them. And
Reese's in there.
I swear I saw one.
there's not a Reese's in here. I can't.
Oh, it's the silver thing.
Yeah, I wouldn't buy it. Those are kisses. Okay. 10.1. If you look, what would you guess that chapter 10 is about? It's about circles. And it is. So we're going to talk about lines and segments. We're going to talk about tangents and then a property of tangents. So, a circle. I was supposed to ask this question before I showed it to you. Can someone tell me what makes a circle a circle? It sure does. But that's not it.
360 degrees.
It is 360 degrees. It's not an angle. What you got?
Does it have to have like a radius and the thing that makes the bigger radius? I forgot. It's like diameter. Yeah.
What do you think? You're correct, but you're not quite there.
It's a 360-degree line.
Think about the difference between an oval and a circle. That's what makes a circle
It
a
has to
circle.
be completely like equal all the way around.
Yes. So it has to have equal distance all the way around. So you don't have to write down the definition, but it means all of these points around the circle are equidistant to the center. What I do want you to write down, you've got a circle at the top of your page. Go ahead and label the center P, and we're going to name the circle. It does look a little different than mine, but I don't care. There's a center. It is how you name the circle. You name it one of two things. You can name it circle P with the word, and you can go ahead and write that under the circle. Or you draw a circle, and you still use the center. So circle P, or you draw a circle, and then that's it. From here, we learn about segments and lines that are in the circle. You've already named two of them, and it's a radius and a diameter, so it sounds like you're on the right track. The top circle that we're going to be talking about, there's two circles there. The top one, you want to label. We're going to talk about segments. So just label, these are segments. Whereas the bottom circle, it's lines. So in the top circle, we're talking about segments. And then in the bottom circle, we're talking about lines. So a lot of you have already seen. We've got a radius, a chord, and a diameter. So you want to label radius, and then I will tell you what to write under it. I'm not going to have you write the textbook definition because I don't think it's helpful. So a radius. A radius is a segment that goes from the center to the edge. So you want to write that down. It is a segment that goes from the center to the edge. So a radius, which you've pointed at right here. This is a radius.
It goes from a segment.
You're looking at the wrong picture. This picture. Center to edge.
Oh, so then I label this one.
Yes. The one that looks just like it, yes. A radius goes from center to the edge. A chord is the next one we're going to talk about. So a chord you've labeled right here. A chord goes from edge to edge. It is a segment that goes from edge to edge. So it is a segment that goes from edge to edge. So a chord is a segment that goes from edge to edge. And then a diameter is the last one. The diameter is a type of chord. It is a chord that goes through the center of the circle. So a diameter is a chord that goes through the center of the circle. So a diameter is a very specific type of chord. It still goes edge to edge, but it goes through the center. So these are segments. Here's why this matters. Whenever you name a radius, you need to name it like a segment. So whenever you name a segment, let's say I wanted to name a radius. How do you name a segment? What does the line look like when I name a segment? Think back to 1.1. A line above it, does that have any arrows? No. And then what goes under it? Yeah, PA. So whenever you're naming any of these, a chord, a radius, or a diameter, you'll name it like a segment with just a straight line above it. The next circle, we have lines. Okay, the first one is a secant. So go ahead and label a secant. A secant touches the circle twice. So a secant is a line that touches the circle twice. So a secant, which is this line right here,
Touches
touches the line twice.
twice.
Correct.
Oh, so it's right now.
Yep, you want to point at the line too. So a secant touches a circle twice. Whereas a tangent, which is on the bottom, this is a homonym to the word you already know. It doesn't mean the same thing, it's just the same word. So this tangent is a type of line. It's not necessarily referring to like sine, cosine, and tangent. It's just the same word. So a tangent, a secant touches the circle twice. What do we think about a tangent?
Touches it once.
Touches it once. Good. So a tangent touches the circle twice, or once. Sorry, I read that. And then the point of tangency is the point where the tangent line touches the circle. So the point of tangency, you don't have to define it. You just point at it. It's pretty simple to figure out. It is the point where the line touches the circle. I have a way to remember secant and tangent. It is dumb, so if you don't like it, you can figure out something else if you want. But here's how I remember. A secant starts with an S, which is a squiggly letter. How many times does a secant touch a circle? Twice, which is a squiggly number. Tangent starts with a T, which is a
Straight number.
straight letter. And it touches the circle once, which is a straight number.
That's pretty smart, actually.
Work smarter, not harder. What is it?
What's the definition of point?
It's the point where the tangent line touches the circle. You don't have to write down the definition. Yes, sir.
You told me to work smarter. I don't think that's possible.
We know.
I wasn't asking for your response, Redhead.
We're moving
No
on.
problem, you shouldn't have said that.
Here we go. So we're going to use that in this diagram below. We're actually going to name everything, not just one or two like it says. We're going to name radii. That's the plural form of radius. We're just going to name all of them. A radius goes from where to where? Center to the edge. So the center here is A. So what is a segment that starts at A and then touches the edge? AB. So it is a segment. AB. What is another radius? AF, correct. Starts at A. All right, and then one more. AD, correct. Now we're going to name a chord. We're actually going to name all of the chords. A chord goes from where to where? Edge to edge. So, what are we thinking? ED. It is a segment, so you just put a straight line above it. We got ED. What else do we have? It's the same thing.
EB.
EC. EB isn't a line. DF is correct. Is the last one. It's the Fantastic Four right there. Or are you guys too young for the Fantastic Four? What? Name a diameter. There's only one here. What is the diameter? Correct. DF. All right, so now we are naming a secant. How many times does a secant touch a circle? Twice. It is a line, so whenever we name this secant, we'll have arrows above it. So what is the only secant in this picture? ED. And then last, there's actually, I don't want to say a typo, a tangent. In order to name a line, this is the tangent, right? In order to name a line, you need 2 points, or you need a lowercase letter. There's only 1 point, and it's B. So we're going to make up a second point, because it should be there. So what point do we want on our line? He said G. So what would we name our tangent? Correct.
Touches one time.
AB would not be talking about the tangent.
Where'd you get the G from? Did you make the G?
We sure did. There should have been another point, or there should have been a lowercase letter. So if there had been a lowercase letter, we could have said line and then that letter. What is the point of tangency? It is B. So you can either say B or you could say point B. Same thing. But it's the point where the tangent line touches the circle. Go ahead and flip. You do want 2 colors out.
Oh.
So either a pencil and a pen or 2 highlighters. In a plane, 2 circles can intersect in 2 points, 1 point, or no points. What does it look like if 2 circles intersect at 2 points? A what? An X?
Looks like 2 of curved.
Correct. There's something that you learned
I
about.
don't
Use a comparison graph, right?
Yes. What is that called? It's a Venn diagram. It's fine. It can look like a Venn diagram. Could look like this. Just 2 circles overlapping. They could intersect at 1 point, and it could look like either of these. And then they could intersect at no points, where they just are next to each other, or one is inside the other. Okay? If 2 circles intersect at 1 point, they're called tangent. That's not the important part. The important part is coplanar circles that have the common center are called concentric. I want you to write it somewhere. I don't care where. But concentric circles are circles with the same center. So you're writing that down? Concentric circles are circles with the same center. Concentric circles are circles with the same center. Concentric circles are circles with the same center. The way that I remember, this one's not as dumb. What does cone mean in Spanish?
Coleman?
With. Okay. So with and then center. Centric. So with the same center is kind of what I think. So concentric, they have the same center. So in this next section, you're going to use 2 colors. You will either like it because you think it's really easy, or it might take you till the end for you to find, like, let it click. Either way, we will get through it. We are talking about something so small and so simple in the grand schemes of math. We're going to talk about common tangent lines. This is actually a concept that we're going to just graze the surface for, but you talk about it a lot in calculus. So you're obviously not in calculus, and maybe you won't ever take calculus, but we need to talk about it. So we're first going to talk about internal tangents. So you're going to have 2 circles, okay? And you're going to have to tell me how many common tangent lines they have. How many times does a tangent line touch a circle? Just the once. So you want a line that touches each circle 1 time. Okay, so there will be internal tangents, which are between 2 circles. And then there will be external, so this is internal. It's between the 2 circles. And then there will be external like this, where it's on the outside of both circles. It may take a second, but it will be okay. Okay, so you're going to take 1 color. We're going to tell how many common tangents the circles have, and we're going to draw them. You want to use 1 color. I'm going to use blue, because that's what it says. We're going to draw external tangents first. So we're going to figure out how many external tangents there are. And then it says use red to figure out how many internal there are. That's why you have 2 colors. We're going to do external first. I'm going to show you why some aren't common tangents and why some are. So don't draw until I tell you. Sound good? Our goal is to get 1 line that touches each circle once. That's the goal. So I'm going to use this circle. Before we even start, I want you to envision what external and internal is. Internal is between them. So what I highlighted in yellow, that is internal. That's between them. What is not highlighted, what's outside of the blue, would be external. So we are trying to have 1 line touch each of the circles once. Do not write until I tell you. So let's say I have a point right here. If I were to draw a tangent line that only touches this circle once, will that tangent line ever touch the other circle? No, this is not a common tangent line. I'm just going to go around the circle clockwise. Nope, counterclockwise. Okay, if I had a point here, remember that we only want it to touch our circle once, so this would not be a tangent line. We're envisioning like this direction. With this line drawn better, would it ever touch the other circle in one place? Yes. So what you're going to do with one color, the external color, you're going to put a dot at both circles, draw a straight line as best you can to connect it. That is one external tangent. So keep that same color because we are not finished. So remember when you are looking, we're looking for external. What's inside, what's between the two circles is internal. We don't need that. We want external. So I'm not even going to like put a dot here and I'm not going to put a dot here and figure it out because that's inside. I still want external. So looking from the top of the circle, I just went around the circle. Is there a way to draw another line, it'd be similar to this one, another line to touch the other circle once as well? Yes. So same color, because it's also external. So you've got two lines. These are two external, and that's how many there are. There aren't any more that would touch both circles. So one on the top, one on the bottom.
Two on the inside, two on.
There are two on the inside. Look at you. It's always not the weirdest. Reagan really got this too, and it surprised me. So the internal, there are two of them. Do you know what they'd look like?
Yeah.
Like what? Oh, you don't have to get up.
Oh, we have to get it. Look, so one's gonna be right here, and the other's gonna be right here, and they're both gonna go straight down, aren't they?
Never mind. Take it back.
I don't got it all.
Our goal is that they touch both circles. So there are two on the inside, but not like that.
Oh, I see. They're at an angle.
They are at an angle.
Yeah,
Good.
I like that.
So he said like this,
Down.
but it wouldn't touch the other circle. It will be at an angle. So you want like on the lower end and on the higher end,
I see.
and cross like that. And then the opposite direction as well.
You know, I got a little banged up this week and my head's still recovering.
Connor. Stop it. So we have two internal. So anytime you have two circles like this, you will have two external, two internal. It doesn't matter what the circles look like or what size they are, that's what's going to happen. All right. So that's the answer. Part B. So in A, they did not intersect at all. In B, how many times did they intersect? Once. I know it's kind of harder to see, but if they intersected more than once, they would make it more obvious like they did here. Okay, so they intersect once. How many external tangents do they have?
Two.
Still two.
And then they have
I'm getting there.
three.
That's not an option. So there's one on the, I don't know what you want to say, left side. One on the right side. So there's two external. Internal, we want a tangent to touch each circle one time. What are your thoughts?
Well, right there on the inside, there's one that can go straight up.
Correct.
Right there on the inside, on both sides.
You lost me.
No, I'm serious. Like if you put two dots on the inside right there, or is that still counted as an external? Because you can make them both touch with a straight line, right now, on both sides.
Are you saying like this?
No. Like
Like this?
No.
Okay. Well, the correct answer is just straight through the point that they share.
Oh, for real?
For real.
I thought so. There's only one internal.
Correct.
I thought there was three.
There's just the one.
See, because if you go like right there on the inside, it looks like you can connect them together.
But you want to touch the circle once, not twice. You would touch each circle twice.
Oh.
Because it's a line. It'll keep on going. Also, I love your notes. I just do.
Why?
Do I what?
You know what the 26 is?
The 26 is. Oh, that's Jason's birthday, ain't it?
C. How many external do we have? 2. And then how many internal will we have?
Zero.
I'll show you why. Remember that a tangent only touches a circle once. So, if I wanted a tangent to touch each circle only once and be between the two circles, there's no between the two circles. When would I have 0 external? I will show you. If I could draw a circle better. It's good enough. You would have 0 external and 0 internal. They don't have anything in common. They're not apart, so there's nothing between them. If one of them was external, like if it was external to that circle, it would touch the other circle twice. So that's when you'd have none. So good question. This one you'd have 0 and 0. The only other thing you might have is 2 circles where they touch at one point, but it's on the inside. So there wouldn't be any internal tangents because there's no space between them, but there would be an external, just one. So there'd be 1 external and 0 internal. There are no other ways to have tangents. This is it. You'll either have them apart like this, touch in one place, touch twice, or those two. That's it. So you're going to try the next two by yourself.
I got this one.
Wonderful.
You have to be color coded too.
You just do it. So how many tangents do we have? 2 of them. They're both external. Look at that. Done.
Yeah.
All right. So now we move on to some math. You probably want a calculator out. That's why my last class took so long. So you're going to write down this property. You'll want to write it next to example 3 off to the side. You're not going to write this. I'm going to tell you what to write. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle. So in this section, it's going to ask you if a line is tangent. To figure out if it is, it's got to be perpendicular to the radius. So what you're going to write is that the tangent line, so you're writing this next to example 3, the tangent line and the radius must be perpendicular. And then I would highlight it. Tangent line and the radius must be perpendicular.
Oh man, I just cracked my pistol.
So what does perpendicular mean to me?
90 degrees.
What else?
Both right angle.
That is exactly what 90 degrees means. They intersect and form 90. So intersecting is important for what we're going to talk about. But they intersect and form 90. So in this question, it says, is ST...
Ms. Marshall?
Yes, ma'am. Wonderful. Okay, is ST tangent to circle P? So go ahead and label ST. We're trying to figure out if this is tangent. So we're figuring out if that is tangent. If it is tangent, then the tangent line and the radius would be perpendicular. So we need to figure out if the tangent line and the radius are perpendicular. Which of these is the radius?
P.
TP.
TP, thank you. Go ahead and mark it as the radius. So in order for this to be tangent, ST needs to form a right angle with TP. So if you take a step back and look at this, we've got a circle, And then what else do we have in this circle? A triangle. So we want to decide if this is a right triangle. How do we figure out if a triangle is a right triangle?
Tangent, sin, cosine.
Right chapter, wrong concept. How do I figure out if this is a right triangle?
Oh, you add them. I see that you did that big 180.
It's a bummer, guys. It's the Pythagorean theorem. So we're going to use the Pythagorean theorem.
How to do that?
It is a squared plus b squared equals c squared. So we're going to use this to decide if we have a right triangle. So yes, C is always the longest side, but what else is C? Where is it always located?
Opposite from right angle.
Okay, good. You want to remember that on the next screen because
See a right angle.
you had to draw it. There needs to be a right angle between the tangent line and the radius. So that's where the right angle is, at T. So that means 37 is going to be C, and 35, and 12. 12 squared is 144. What is 35 squared? Correct. And what is 37 squared?
Doing that math.
Wonderful. What is 1225 plus 144? Correct.
So it is a right triangle.
So it is a right triangle, which means that they are perpendicular. So is ST tangent to the circle? Yes. So you're going to put yes. It doesn't say explain, but I do know on the test
It will.
or the quiz it does say explain. So all you need to write to explain is that the tangent line, so we'd say because the tangent line, or the tangent, however you want to say it, and radius are perpendicular. So if it says explain, that's how you explain. In the diagram, point B is a point of tangency. Find the radius r of circle C. So a point of tangency means there is a tangent line. So B is the point of tangency. So what here is the tangent line?
BA.
Yeah, AB, BA. Wonderful. Go ahead and label it as your tangent. This is why it's important. A lot of people look at this question and they're like, 80 is the biggest number, it's the hypotenuse. But you would be incorrect. And I will show you how. The tangent line and the radius are perpendicular. So perpendicular means they intersect and form 90. There are two radiuses marked here, but one of them is going to form 90 with the tangent and one of them is not. This one does not touch the tangent line, so it can't be perpendicular. It doesn't intersect. So this one does, which means the right angle is right here. Let's go ahead and draw in the right angle, which means which of these sides is the hypotenuse?
50.
Almost.
R.
It's both.
50,
That whole-
50 R.
Not quite.
50 plus.
50 plus r. AC if you want to call it. Either way, that's the hypotenuse. If you want to label it as the hypotenuse, you can. It's the hypotenuse, and it is officially 50 plus r. So, to find the radius, this is a right triangle. We are going to use the Pythagorean theorem. A squared plus b squared equals c squared. So what are a and b in this picture? 80 squared and r squared. Good. C is the hypotenuse. And this is where you have to, this is the algebra part. I want to square all of the hypotenuse. What is the length of the whole hypotenuse? 50 plus r. How do I show that I want to square the whole side? Parentheses. You do not want to square both. This is on the PERT, being able to deal with this. Okay, we're going to do the easy stuff first, though. What is 80 squared? What's 8 squared? 64 and then
640.
6,400. Plus r squared. So, when something's being squared, what is happening to it? It's multiplying by itself. So this is the same thing as 50 plus r times 50 plus r. And that is the exact way that you need to write it. It is not, it does not make 50 squared plus r squared. It just doesn't. And if you write it like that, if you just square it like that, you're going to get a very, very wrong answer. Okay, so I'll show you what we're supposed to get in comparison to if you did not math. So, we want to multiply 50 plus r times 50 plus r. What needs to happen is you're going to end up distributing 50 times 50 in r, and then r times 50 in r. There is an acronym that they use to help you remember. Does anybody remember what the acronym is? It's 4 letters.
Unit.
It is FOIL. Wonderful. First, outer, inner, last. So we're going to distribute using FOIL. So first, he's just distributing 50 times 50 and 50 times r. That's what our first thing we're going to do. So 50 times 50 is 2,500. That was first. Outer would be the outer 50 times r, which is 50r. Okay, inner, now we're going to distribute the r in. So r times 50, which is 50r. And then r times r, which is
R squared.
r squared. Take a moment to appreciate our answer versus the wrong shortcut. The left side didn't change. So we have an r squared, which normally whenever you see an r squared, you want to ask if you have to factor. But if you were to move either of these r squareds, how would I move a positive r squared across the equal sign? I would subtract it. What happens when I subtract r squared on both sides? Cancels on this side, right? R squared minus r squared cancels. What happens on the right side? It also cancels. So do we have any r squares? No. So this is now like a pre-algebra problem. 6,400 equals 2,500 plus, what is 50r plus 50r?
100.
100r.
So we need to subtract the 2,500.
Correct. So subtract 2,500. 6,400 minus 2,500 is 3,900. Divide by 100. R equals 39, and it would be feet. So, just to show you, the hypotenuse is still the longest side. It was 50 feet plus whatever the radius was. And what was the length of the radius? 39. So what is the full length of AC? 89. So still the longest side. All right, we do one more. This one's super simple. If you have two tangents that have the same external point, then the tangents are congruent. So RS and TS, they intersect at S. They are both congruent to each other. So if the length of RS was 5, the length of TS would be 5. So that's what we use. You got two tangents that intersect at R. Find the value of X. We know that they're going to be congruent to each other. So if the length of RS is equal to 28, what is the length of RT equal to? 28. Subtract 4. 28 minus 4 is 24. Equals 3x. Divide by 3 and x equals 8.